Good morning, everyone. Today we will directly go to master slave flip flops, okay, or pulse triggered flip flop, okay. When we discussed the concept of edge triggered flip flops, in the case of JK flip flop, we came across the topic called toggle or the condition called toggle. When the value of J and K was equal to 1, we saw the output or the state of the system will go to toggle condition. That is, if the present state was 0, the next state will be 1. If the present state was 1, it will be 0 in the next case, the next state. Okay, but there is a problem in the case of what we call the edge triggered flip flop. Okay, that is that we will go directly into this topic. The condition or the problem, the name of that particular problem is called race around condition. Race around condition. Okay, that is, it's a condition in which the values, that is the toggle condition, persist and the values will change based on the clock pulse width. The value will change, that is 0 will be converted to 1, and within that time period that 1 will be converted to 0, 0 to 1, 1 to 0, 0 to 1, 1 to 0. Likewise it continues, and when the clock pulse stops, it will be in a particular state where we can't predict the output precisely. Okay, that is called the race around condition, and this phenomena can be prevented by the introduction of master slave flip flops or what we call the pulse triggered flip flop. Okay, and what do you mean by in the case of pulse triggered means we, for the particular operation, we utilize a complete clock pulse. In the case of edge triggered, we either use the positive edge or the negative edge. Operations takes place. Okay, but in the case of pulse triggered, the total time is the time taken for the time consumed by the total clock pulse. Okay, and in that also we come across the positive edge and negative edge together. Okay, so the time will be one clock pulse as a whole. Okay, clear? So we will go directly into the notes part. Master slave flip flop or pulse triggered flip flop. For the JK flip flop, that is in edge triggered concept, consider the assignment of excitation J is equal to K is equal to 1. If the width of the clock pulse, this is TP, T subscript P, TP is too long, the state of the flip flop will keep on changing from 0 to 1, 1 to 0, 0 to 1 and so on. And at the end of the clock pulse, its state will be uncertain. This phenomena is called the race around condition. Race around condition. The outputs Q and Q bar will change on their own if the clock pulse width Tp is too long compared with the propagational delay tau. Okay, this is a symbol tau of each NAND gate. Okay, so no need to go directly into the to depth of this particular condition. We can have a lot of concept based on this. Okay, theories based on this, but I will say that, definitely say that it's enough. That is the race around condition. What is the concept behind it? What is the reason for such a shift of 0 to 1, 1 to 0, 0 to 1, 1 to 0, and why is there uncertainty occurring? Okay, in order to avoid or in order to what we call tackle the problem caused by race around condition, we go for the master slave or the pulse triggered flip flop. Okay, please go. Thus, the reason for introducing master slave was based on the what we call to avoid race condition. Okay, so as it is pulse triggered, that is, as I told earlier, when we consider a pulse, it should be based on both positive edge triggering and negative edge triggering. Okay, so a non-pulse or the time is introduced between the application of the clock pulse and the time when we receive that particular output. Okay, it will be clear when we go for the next step, but for the time being, let's discuss the rest of the operations. The master slave flip flop was developed to make the synchronous operation more predictable. That is to avoid the problems of logic race, that is race around condition in clocked flip-flops. This improvement is achieved by introducing a known time delay equal to the width of the clock pulse between the time that the flip-flop responds to a clock pulse and the time the response appears at its output. The master slave flip-flop is also called pulse triggered flip-flop because the length of the time required for its output to change the state equals the width of one clock pulse. Okay, but the operation will be discussed very soon. It's that is the one that you need to understand. Okay, about the master slave flip flop, because based on that we have the classification as well, and the classification that will be mainly it is mainly classified to SR, JK, and D. Okay, please go through. The master slave flip flop consists of two sets. Okay, one is the master flip flop concept and master flip flop, and other is the slave flip flop. Okay, and basically the operation is based on, as I told, it's pulse triggered. I am repeating the same case. As it is pulse triggered, it works on both the positive edge trigger and also the negative edge trigger. Okay, so how does it work? During the positive edge triggering, okay, or the during the positive edge of the clock pulse, okay, based on the input and also the clock, that is the clock means the clock, we have the clock, and also on the positive clock, what happens is that the input, the control inputs, okay, based on the control inputs, we will give the input to the master flip flop or the master case or the master section, and we will determine the output of the master. Okay, determine the output of the master. And during the negative clock pulse, okay, this what is the stage of or what is the output we received from the master flip flop, that will be transferred to the slave flip flop. Okay, that is the basic working. Okay, so there will not be there will not be, it's based on two conditions, right? That is the positive edge trigger and the negative edge trigger. So there will not be race around condition, that is there will not be any uncertainty of the values regarding the output when the value of j and k are equal. Okay, when equal to 1. Okay, thus we say that the master slave flip flop actually contains two flip flops, a master flip flop and a slave flip flop. The control inputs are applied to the master flip flop and maintained constant for the setup time Ts prior to the application of the clock pulse. On the rising edge of the clock pulse, the levels on the control inputs are used to determine the output of the master. Okay, during the rising edge of the clock pulse, the levels on the control inputs are used to determine the output of the master. On the falling edge of the clock pulse, okay, that is on the falling edge of the clock pulse, the state of the master is transferred to the slave, that is the outputs are Q and Q bar. Okay, the control inputs must be held stable. Okay, that is the next concept that we will learn after the master slave flip flop. The control inputs must be held stable while the clock is high. Okay, otherwise an unpredictable operation may occur. Okay, that is the control inputs must be held, that is we give the inputs and those inputs must be held stable while the clock is high, otherwise an unpredictable operation may occur. This problem is overcome with an improved master slave version called the master slave with data lockout. Master slave with data lockout. We will definitely discuss about this particular topic, that is master slave with data lockout, by the end of this particular video. Okay, please go through. This is the logic symbol for the three kinds of flip flops, that is master slave SR flip flop, master slave D flip flop, and master slave JK flip flop. And here we can see that what are the differences when compared to the previous kinds of flip flops. Okay, we have clock here, similar, but we don't have arrow marks or the triangle or the bubble in order to show that when there was triangle in the case of edge triggered, it meant that it was positive. Okay, and when there was a bubble and a triangle, it was negative edge triggered. But here both the positive edge triggering and negative edge triggering comes into action. So what we do is we give a clock signal. Okay, that is it's pulse triggered flip flop. That is a full pulse is used. So the clock just give a line. Okay, in order to show that it's clock. Okay, just give a line to show that it's clock. And we have another symbol. It's drawn like this. It shows that it's the we have the postponed output. Okay, postponed output means when it's based on the output depends upon both the positive edge trigger, that is the master, and during the negative edge triggering, the output of the master is given to the slave. Okay, so when compared to the previous cases, in order to show that it's master slave, there will be the output will be we obtain will be a postponed kind. Okay, so we should say that this symbol shows that the symbol shows that it's the postponed output. Okay, please go through postponed output or the postponed output symbol.